Assalamualaikum student, welcome to daily physics lecture. Today in lecture 6 we are about to discuss about an interesting circuit. I hope you obviously know, and we will see that this circuit is parallel or series. Okay, so let's start the class. So students, you can see that there is a very simple series circuit, and this circuit has 4 resistors in series, 1, 2, 3 and 4, and I just pointed here. I just put some points here. This point is P, which is the starting point after the cell. Here we have point A, point X and point Y, and we have point Z. So what will actually happen? Suppose the EMF of the cell is 100 volt. So all electrons, those will leave the cell, all those electrons will carry 100 volt, and when they reaches at point P, suppose here at that point, as P is just outside of the cell, so here all electrons will carry 100 volt, and usually we assume the lines are resistance-less. So from here to here, the starting point of the resistance 1, suppose this point is Q. So from here to here we have a line. So from here to here no potential will used by the electrons. So electron will not use any potential. So that means the potential at point P, which was supposed to be 100 volt, will be same as the potentials at point Q. So potential at point P and potential at point Q are simply same, which means this P and Q are same points. As their potentials are same, so obviously these two are same point. So we can write this point Q as also P. If we have many points in between these two, this is also P. So here in a line all points are denoted as same, because in a single line no potential varies. Now from P to A, obviously potential varies because we have a resistance here, it will use some potential. So at point A we will not get 100 volt, we know it. Now if I use a short line, I have already discussed about the short line in another lecture. Let's suppose lecture 2. In lecture 2, the tail of shorts, I have already discussed about the short line in lecture 2 as the tail of short lines. And suppose we have added a short line in between point X and Y, then what will happen? So short line, here we have a short line, that means the potential at every point on these lines are same, and short line means no resistance. So short line will convert this X, which was one point, and Y, which was another point before there was a resistance, and now despite of a short line these 2 points will be same, because in a single line potential doesn't vary. So X point and Y point now become same. How? So what will happen if these 2 points become same? This resistance R3 will now look like this. So now you can understand, as these 2 points are same, so what will happen? This R3 is now out of the circuit. So unlike initial, how many resistors do we have? As R3 is now out of the cell, out of the circuit, so we have now 1, 2 and 4 resistors. The R3 is washed out. Okay, so we can take this R3 and remove it. So now we have only 1, 2 and 3 circuit. So what actually short do? It converts 2 point, it exactly joins 2 point into 1. I hope you get it. So now I'll discuss about another problem which I already mentioned, that will be easier to understand the working procedure of shorts. Students, please look at this circuit. You are already familiar about this circuit because I have given you a HW regarding this circuit. So now here, there's the cell. There are 2 resistors in parallel, and with these 2 we have R3 in series. So it's a mainly series circuit. Now interesting matter is that there was question 2, and that question 2 was told us that if we add point A and B, then will current flow vary or not? And we know that current flow depends upon the total equivalent resistance of the circuit. So now we have 2 parallel and 1 in series, so we have 1 type of current flow, and if we add this point A and B by a short line, then what will happen? I say 1 line, 1 point. 1 line, 1 point. So if this point is A, because we are starting from here, so if this point is A, then this should be A, this should be A, this should be A, so this B point will be also A. So as all these points are A, because they are in the same line means same point, so all those current which will reach here, this will definitely reach here, because these 2 are not different point, these 2 are the same point. So no current will flow through R3, so R3 will be washed out. There will no presence of R3. So now as R3 will be washed out, so now we have this circuit. These 2 are in parallel, and only these 2 are in parallel, there is nothing else. So I hope you understand what exactly short do. It exactly make 2 different points into 1 point, because in a line potential doesn't vary. So starting point of the line and end point of the line will have the same potential, which means these 2 points are same. So short makes 2 different points into 1 point, converts 2 different points into 1 point. Okay, so now let's get back to real problem which I was supposed to discuss here in this lecture. So let's discuss about our desiring this circuit. So here, before adding shorts, this circuit look like this. Here, this is a very simple series circuit. We have R1, R2, R3. These 3 are in series. So if there are no shorts here, if we don't add any short, then the equivalent resistance of this circuit will be simple. R1 plus R2 plus R3. But what if we use a short? Okay, so just tell me one thing. Suppose the starting point of the circuit, at the starting point of R1, if this is A, then this point should be A, because no resistance, so that means these 2 points will be same. And here, suppose the ending point of R3, that is all the resistance, this is B. So this point should be B, this point should be B, and this point will also be, because from here to here we don't have any resistance. So resistance less means it's a normal line, and we know in a normal line every points are same because they have the same voltage. So now as it is now look as series circuit, so what if we add 2 shorts? So let's add short number 1. it starts from point A and ends at the ending point of R2 and starting point of R3. Here, I will get it. And let's use short 2. It starts at the ending point of R1, which means here, and the starting point of R2. And it ends at the ending point of R3, here. So these are two shorts. So we know shorts exactly converts one point to other. It exactly links 2 points into one. So if this point is A, this is A, so here it will be A, here it will be A, this point will be A, and this point will be A2. So all these points are A because of the short. So short converts our this A into this A. So here this point is A and this point is also A. Short creates it. And about the short 2, here we know this point is B, this point is B, right? So this should be B, this should be B, this should be B, and this point should be B2. So now we can see we have all over everywhere, this is A, this is A. So the main perspective of short is to connect the point. So if this is A, this is A, we have already done with this short. What exactly it do? It converts this point into this point. Okay, these two are A. So we already discussed, we already have the result of this short. Why are we using it? Because we already know this is A and this is also A. Right? Because of the short. We already have the short. I'm just erase it. I know there is a short, and that's because this point is A and this point is also because of the short. And I'm now also erasing the other short. This short is present. Because of the short, this point is B and this point is B. So now we have a weird circuit. This is A and here we have another A. So these 2 points are same. How? This is B and this is also B. These 2 points are same. How? We have resistance everywhere. So let's take this resistance and make these points A's at the same point and B's at the other same point. So let's take this R2. Look, this is it, B. This point is B. This is also B, right? So I'm not changing the points. This is B and this is also B. This is A and this point is also A. So this point is B. Look, we have B here. This point is A. Look, we have A here. So let's take this A into this point and take this B into the other point. This is also R2. So 2A at the same point, 2B at the same point. At the same point, 2B at the same point. And now take 2. This is A, this is B. And again let's take all these A's at the same point and all B's at the same point. So now look at this circuit. All A's are at the same point, all B's are at the same point. And now this add these points. This one is B, right? And this is also B. Now just tell me how this circuit looks. R3, R2 and R1 are now in parallel. So because of those short lines which converts one point into other, right, which joins the similar points, we now get 3 point A and all these points are at the same place and B at the other place, and now that series circuit now converts into a parallel circuit because of the short. So now initially these resistors were in series, and now because of the shorts they are in parallel. So we know now how to solve this circuit. So this was the end of our lecture, and please, if you understand this thing, please share this lecture to your friend and let me know if you have any problem through the comment box, and stay inside of your house, stay safe. We will see tomorrow. Thank you. Allah Hafiz.